Okay, so as in the last video, we have discussed or we have revised the three important formulas by what we can calculate the number of moles, right? There were three important formulas. The first formula was on the base of the mass, right? If there is given mass in the question, then you can find the number of mole by dividing that given mass per the molar mass of that particular substance. You can get your number of moles, right? The second formula was when the given particles are given in the question, then you can divide those given particles by the Avogadro's number, which is equal to 6.022 into 10 to the power 23 particles, and then you can get your number of moles, right? The third formula was on the base of volume. When there is a volume given in your question, then you can divide that volume by the molar volume, and molar volume of any gas at STP is always equal to 22.4 dm3. When you're going to divide your given volume by the 22.4 dm3, you will going to get your number of moles, right? So we have revised three important formulas which we will be now using in the stoichiometry when we'll be solving or when we'll be calculating the number of moles, volume or mass or the number of particles in the chemical equations, within the chemical equations. Here we were just were solving simple equations, right? We were doing simple simplifications, but here now we will gonna apply our mole concept or apply these all concepts we have learned till now on the chemical equations. Now we are going to start our stoichiometry, right? So now, for suppose if I have a question, the question is, if 16 gram of methane, we know that what is methane? It is CH4, right? Methane is burned. Find mass of carbon dioxide produced. Carbon dioxide produced, right? We need to find the mass of the carbon dioxide produced when we are using 16 gram of methane, right? So either the question which is asked to you by a person, he can provide you with the balanced chemical equation, or he can only provide you the unbalanced chemical equation as well. Then you need to balance that particular equation first, right? For suppose in this question we don't have a balanced chemical equation. They have just given us CH4. When it is burned in presence of oxygen, it produces carbon dioxide plus water. Now it is not balanced, right? How it is in balance? Let's see. Carbon is 1 here, here carbon is 1, means carbon is balanced. Let's check about hydrogen. Hydrogen are 4 here, and here hydrogen are 2, means it is in balance, right? Oxygen are 2 here, here 2 plus 1 3, means oxygen are in balanced as well. Now we need to balance this particular equation, and we know that we have already learned the trick of balancing the equation, right? The ABCD1 trick. So let's balance this particular chemical equation by that ABCD trick. I am going to balance here, right? What was the equation we have? CH4 burned in the presence of oxygen produces carbon dioxide in presence of water, right? Now we need to balance it. For balancing this particular equation, we need to give it a variable, right? A, B, C, D. This is just the revision of the balancing of chemical equations, since we have already learned how to balance the chemical equation. This is the best trick ever. Best trick ever, which is 100% correct, right? Here you're gonna get your answer 100% correct of balancing the chemical equation. Now you need to form the equations, right? Let's form the equation for the carbon first. I'm doing it very fast, very rapid, since I've already taught you this how to balance the chemical equation by the trick, right? So here 1a means A is equal to, here carbon is also 1, so A is equal to C, right? A is equal to C. We have got our one equation. Second, right? So here oxygen, hydrogen are 4, means 4A is equal to, on the product side I have hydrogen 2D, right? So hydrogen are 2D. Now let's check for the oxygen. 2B is equal to 2C plus 1D or only D, right? D. So now we need to solve. Now see what variable we have in two equations or more than two. Of course that is A. We can take D as well, since D is also there in the two equations, but I am taking A, right? So let's suppose A is equal to 1. Suppose A is equal to 1, right? When we have made our A equal to 1, so A is equal to 1, so A is equal to C, right? Means C value will be equal to 1 as well. We have got our two values, A is equal to 1, C is equal to 1. Now let's put this A's value in this equation to find the value of D. So 4 value of A is 1 is equal to 2D. 4 is equal to 2D. When 2 is multiplying here, when we go there it will be divided. So 4 upon 2 is equal to D. Thus we will be getting the value of D as 2. Right? We have got value of D as well. Now let's find the value of what? The value of C now. So by using the third equation we can actually find the value of C as well. So 2B is equal to 2C plus D. The value of B we don't have, right? So value of B we are actually finding it. So 2B is equal to 2. The value of C is 1 plus the value of D is 2, right? So 2B, 2 plus 2 is 4. B is equal to 4 divided by 2 is 2, right? So we have now got our four values A, B, C, D. Now let's put these values instead of these coefficients we have supposed in our chemical equation, right? So let's put this now. CH4 burnt in the presence of oxygen produced carbon dioxide in presence of water, right? So the coefficient A was with methane, and the value of A is what? It is 1, means I can either write the value of 1 or not, since it is also represented as 1 here, right? So B is equal to 2, and B we have with oxygen, so 2O2, right? C is equal to 1. It's not necessary to write here 1, right? It is also representing 1, right? So value of D is 2, so here I'm putting 2. Now you can see this equation is balanced. How this equation is balanced? Carbon is 1 here, carbon on the product side is 1 here too, means carbon on the both side is balanced, right? Now see hydrogen. 4 hydrogen here on the reactant side, 2 2s are 4 on the product side, means hydrogen is balanced as well. Now let's take an example of the oxygen, right? So oxygen 2 2s are 4. On the reactant side we have oxygen 2, 2 here and 2 here, means 2 plus 2 4. 4 on the reactant side, 4 on the product side, means oxygen are balanced as well. Now this equation is thus called balanced equation. Balanced chemical equation, right? Balanced chemical equation. How we did balanced it? We have just supposed variables or coefficient. We have just given variables as coefficient to every substance which is present in the chemical equation as A, B, C, D. We have made the equations, then by considering the reactant side and the product side, and then we have solved those equations. We've got four values A, B, C, D, and we have just substituted those values inside the chemical equation. We have got our balanced chemical equation. Right now, how I'm gonna read it out. The methane, 1 mole of methane burns in the presence of 2 moles of oxygen, produces 1 mole of carbon dioxide and 2 moles of water. This is how we can read this chemical equation. So basically this video length is going to be more, so I'm just going to end this video here. In today's video we have learned about balancing chemical equation. Initially we have learned about balancing chemical equation, but you can say this was only the revision for balancing the chemical equation trick, right? So we have today revised the balancing of chemical equation. In the next video we're going to continue solving our this question, right? Since we balance this chemical equation here by the trick, now we'll be using this balanced chemical equation here and we're going to solve our question.